Question 3 on polynomial capstone practice test B. This one we're looking for a true statement. All right, and there's only going to be one possible answer. You can tell because you've got radio buttons here. That's what they call them, radio buttons, when they're just circles versus the squares, which is when you can select more than one. So keep an eye out just for your directions, but that's another clue when you're working through questions to make sure that you understand how many answers you're supposed to be looking for. All right, so I can answer this one pretty fast, but I want to use it as a review because who knows what you're actually going to get on the capstone in terms of difficulty. So let's start off with what do we know? Well, the first thing I see is I've got a leading coefficient that's negative. Now, the leading coefficient tells you the direction of the right-hand arrow, the end behavior on the right-hand side. If it's a positive leading coefficient, it goes up. If it's a negative leading coefficient, it goes down. This one is negative, so we know that it is going to fall to the right. So we know that much so far. The next clue is going to come from whether this is an even or odd function. Even or odd. All right, if it's even, we know that the direction of the arrows will go in the same direction, whether it's up, up, or down, down. If it's odd, they'll be in opposite directions, whether it's down, up, or up, down. Okay? So the easiest way, in my opinion, to figure out whether something's even or odd is simply to count some x's. Beware for things like that have a multiplicity, that have squares and cubes and things, because remember, if I square the quantity x minus 3, it really means that I have x minus 3 twice there, right? I could replace this guy with those two. And then it becomes a little more obvious when I count my x's. I have 1, 2, 3, 4. All right? If I'd been just looking at it here, I probably would have counted something like 1, 2, 3, 4, just to make sure that I was being thorough. So if we know this is an x to the fourth, right, so we know this is an x to the fourth term, that makes it even. So that means they go in the same direction. So we've isolated that it's going to fall to the right, so that must mean that it's also going to fall to the left. All right, so it's a down, down type of thing. So let's start kind of getting an idea of what ours would look like. Down, down. All right, the third thing, since it's all nice and factored prettily for me, is that I can go ahead and get my zeros. I see that I have a 0 that's going to be a cross at x equals 1, right, because it has an exponent of just 1, so it just is going to cross the x-axis, no bouncing, no wiggling. I'm going to have x equals negative 2, also a cross, because the exponent there is implied to be a 1. And then we're going to have x equals positive 3, and since it's an even power, it's going to be a bounce. So we can put in those values, so 1, 2, 3, negative 1, 2, 3, that should be enough. So we have a positive 1, a negative 2, and a positive 3. And we know it's going to do something like this. It's going to start from the bottom. It's going to go up. It's going to do some sort of a curve. Oops. Maybe something quite not. Hang on. It doesn't. I hate it when they decide that what shape I want. And then this guy is a bounce, which is how we get it going back down again. Okay, sorry, that didn't quite fit, but you get the idea. All right, and so we have a good idea of the picture. There's one other feature in here that two others, I guess. It asks about relative minimums and the y-intercept. Well, the relative minimum is right here, and there's only one of them. There's no other loop that goes down like that. So there's only one relative minimum. And then the y-intercept is going to be somewhere up here. Now, where it actually is pretty easy to calculate, because we know that the y-intercept happens when you are at an x-coordinate of 0. So if x equals 0, then what does y equal? That's the y-intercept. So I'm just going to take my original function up here, and I'm going to plug in a 0 and calculate it. So it's going to be negative, and then 0 minus 1, 0 plus 2, and 0 minus 3 quantities squared. So here we go, negative times negative, right? Because it'd be negative 1 inside of there. It gives me a positive 1 times a positive 2. And then I have negative 3 quantities squared, that's 9. So 2 times 9 is 18. That jives with my little picture here that I just kind of guessed it to where it was going to cross, but it would have crossed at y equals 18. So if we look at our list of choices here, we could have, like I said earlier, we could have answered this question pretty fast, but this is a good review anyway. The function has an x-intercept at 1. That is a true statement. We could have gotten it from right there. So that's going to be the right answer, but I'm going to just triple check, make sure that I don't have anything else that contradicts. It rises to the left, falls to the right. No, it's a fall. And only has one relative minimum, and the y-intercept was at 0, 18. So I feel good about our first response. But of course, we have our wonderful friend Desmos. And Desmos could actually help us out with this, just to make us feel nice and confident that we've got it right. We're going to just plug in that original function. And x plus 2 and x minus 3 quantity squared. There we go. Yep. So I'm betting like that's 18. Yep. And there's negative 2, positive 1, positive 3 with the bounce. If I make this a little bit bigger, you can see the spacing on the Desmos. If you want to be careful, you make sure you zoom in so that you can really see what they look like. And if you click on the graph like I just did, right, it gives you these options to hit the dots that are important, the important dots. All right, good. Feeling excellent about that question.